Hi everyone, this paper we introduce the CloudX system which allow crowdsourcing application for smartphone sensor systems to achieve highly accurate training datasets in activity recognition by addressing three main remaining challenges. First, the collected labels lack inaccuracy as workers are typically not experts in the field and may not be specifically trained for labeling. Second, workers often lack motivation and success engagement. Although they exhibit every enthusiasm, workers may lose interest and drop over time, or might not be highly invested in producing in high quality labels. And finally, the lack of success engagement and motivation as a reason for cheating behavior in crowdsourcing scenarios, which affect the task outputs. So this situation leads to low quality data collection and biased data. We assume this as inaccurate data and propose a method to detect these situations. Based on the remaining challenges of crowdsourced data labeling, we set three research goals to achieve them. First, we employ an active learning algorithm to address lack of accurate labels. Second, we apply gamification concept to overcome lack of motivation and sustain engagement. And finally, we propose an inaccuracy detection algorithms using supervised machine learning to minimize inaccurate data in crowdsourcing applications. Here we summarize a high-level view of proposed systems CloudX, where we propose two novel independent ideas that directed to the same goal on the right side in order to get high-quality training datasets for activity recognition. First, we employ active learning to improve recognition accuracy and user engagement. We first ask the worker to perform the labeling task using hours provided under smartphone application. And then we build active learning model, a special case of supervised machine learning, to train the data from cloud level data. We then build the system to evaluate and provide a confidence score for each levels at gamification points. Then we provide those points to user through smartphone notification. So here worker can easily understand how well they complete the labeling task by looking at the score, and then they can optimize data for their data labelings. And on the right side, we then expect that we can get accurate training datasets that is ready for use for our activity recognition systems. And for the second methods, we also ask the worker to perform the labeling task using same period and the smartphone application. And here we build inaccuracy detection model to train the data from cloud level data. And then we build the system to detect inaccurate labels from cloud level data. In this stage, if our system detects inaccurate labels from cloud level data, we provide results immediately to user through smartphone notifications. So worker can get a notification that the system has detected inaccurate data from their data labeling task, and then they can avoid making inaccurate data for data labeling. So that's why on the right side we expect that we then get accurate training datasets same as the previous methods. To evaluate the differences between the three conditions, we design a large-scale activity data gathering systems, including Trackation, Task Mobile Application, and Task Manager. We collected variables that may impact labeling performance, including age, gender, digital literacy, smartphone usage, smartphone gaming, and working hours. We collected over 6,000 activity labels from 19 activity classes, and overall participants in the two proposed conditions submitted small label and more one class on average compared to baseline condition. We also apply user-dependent training for evaluation to show accuracy improvement for each participant in each condition without considering side effects such as different sensor position. We also apply user-independent training to show overall accuracy improvement in each condition that can be applied to new users. And also we assess the varieties of the crowdsourced data to determine whether the accuracy levels are sufficiently high for application to real-world data or not. We then measure the user engagements by using two popular approaches. First, the user engagement scale, short form USE, and second, we recorded the user events including button press on the smartphone application and click-through rate (CTR) of push notifications. We further explore the relationships between the number of button presses (CTR) and activity recognition accuracies. We show that the correlation between variables by using regression analysis and the network plot. We also show average percentage of inaccuracy in the collected data. In summary, we proved that all our research questions were supported, and why did research enable us to effectively collect crowdsourced activity data. There are also limitations to be addressed for future research. So if you interested in this research, please read this paper in details, and also if you require any further information, please feel free to contact me by email.